Hey guys, welcome to this live session by Great Learning. In today's session, we'll be understanding a bit of NLP and we'll see how to perform text to speech. Now, before I start off, just give me a confirmation if you guys can hear me and if you guys can see my screen. And if all is well, we can just go ahead with the session. And I just wait for some of the other folks to join in. And till then, I'd like to inform you folks that we have launched a free learning platform called as Great Learning Academy, where you have almost 100 courses with respect to domains such as AI, stats, digital marketing, and a lot more. And the best part is all of these courses have been taught by industry experts, and these industry experts have their masters and PhDs from Ivy League schools such as Stanford, UT Austin, and if you talk about India, so most of these lecturers are from IITs and NITs. And the best part is once you complete these courses, you will have a course completion certificate. So you can add that course completion certificate onto your resume or onto your LinkedIn page, and that will be a huge value add for you folks. And so you'll find the link for this in the chat. And if you're someone who wants to learn through an app, we also have the Great Learning app, and you can find the link for the app as well over here. And also, all of the attendees who have just joined and you are new to our channel, I'd request you folks to hit the subscribe button and also click on the bell icon, as you'll be getting a notification for our new videos. And this will also encourage us to keep coming up with more such live sessions and also upload a lot more high quality tutorials so that your lockdown is as productive as possible. So also, I'd want this session to be very interactive. So wherever you have any questions, you can add them in the chat, and I'll take care of all of those questions. Now, today's will be a short session. So today's session would be around 30 to 40 minutes, and it'll mostly be a demo session. So we'll just start off by understanding what exactly is NLP, what is the need of NLP, and then we'll look at some. There's a package known as NLTK, which stands for Natural Language Toolkit, and with the help of this Natural Language Toolkit, we can perform simple NLP operations such as tokenization, lemmatization, named entity recognition, and so on. So we'll be performing some of those basic operations, and then we're going to perform a very simple demo where we'll convert whatever text is present into speech. So it'll just be a 6-line or a 7-line demo, and all of you folks can perform it. So this will not be a complicated session. This will be a very simple session. And also, if you want the code file in the PPT for it, the link for that also will be present in the chat. You guys can go ahead and also download the code for this. Now, before I start off with the session, I have a question for you folks. So answer this. How do humans communicate? Now, if humans have to communicate, they would need a language, isn't it? And whatever language humans speak, that language is known as natural language. So whether you're speaking English, French, Spanish, Hindi, Telugu, Malayalam, whatever language it is, so the language which humans speak, that is known as natural language, because this is the language which naturally comes to us, and this is how we are able to communicate with other humans. Now, what about a machine? So let's say if I speak in natural language to a machine, will that machine be able to understand? So this is where the domain of natural language processing comes in. Now, you can consider natural language processing to be that domain of artificial intelligence where we actually teach a machine how to understand the natural language. And what is natural language? Natural language is any language which a human is able to speak. Now, here we have a simple example over here. You would have worked with a lot of virtual assistants. You would have worked with Siri, Cortana, Google Assistant, and all of them. Right now, let's say if you just ask Siri, am I the most handsome person on this planet? Then Siri will definitely give you a reply. but it's just a machine, isn't it? It's just a computer program. So how is Siri, a machine, able to understand this natural language spoken by us? So this is what happens with the help of natural language processing. So in natural language processing, we are able to understand whatever a human is speaking, and that natural language is converted into machine understandable language. And this is the basic idea behind natural language processing. So now this is clear, we'll just go ahead and look at some basics of natural language processing. So we have something known as tokenization, lemmatization, named entity recognition, and POS tagging. So we'll be performing all of those basic operations with this package called as NLTK. So I'll just go ahead and check if there are any questions. So guys, if you have any questions, you can ask all of those questions over here in the chat. I'll parallelly take up all of your questions. So let's make this session interactive. Now your questions could also be with respect to data science, AI, or data analytics in general. They don't have to be, they don't exactly have to pertain to this particular session. I'd love to take them up. Right, so now that we've learned the basics of this, we are going to the Jupyter notebook over here, and we have this simple demo. Now, as I've already told you, to implement all of this, we would need a library called as NLTK, as you guys see, and NLTK stands for Natural Language Toolkit. Let me just go ahead and import this library first. So if some of you folks are new to Python and haven't really worked with Python, then we have a lot of packages for different purposes, and NLTK is one such package, and this is used for implementing NLP operations. Now, once we import this, we would have something known as a corpus. Now, a corpus in general, let's remove the computer jargon over here. So when you talk about corpus, corpus is basically a collection of different items, or basically a huge collection of items. And with the help of when we import nltk.corpus, we would have a lot of inbuilt text inside this. So that would provide us with a lot of inbuilt text, and that would also provide us with a lot of functions. So that is why we are importing this as well. Now, when you talk about any language, the basic component of a language is what is known as a token. Now, if you want to make a machine to learn the human language or the natural language, then the machine has to understand each individual token properly. So here what we do is we have this concept of tokenization, and we can either consider a single letter to be a token, a single word to be a token, or a single sentence to be a token. Now that totally depends on how we are wanting to train the machine or what our problem statement is. So we have this module called as nltk.tokenize, and from this we have this method which we are importing. So we are basically importing the word tokenize method from this module called as nltk.tokenize. Now I have a simple sentence over here, and I store that sentence in this object, and the sentence is Samay Raina is the best chess streamer in the world. So now once I store this in this object, let me just run this again over here. Or I store this in this object. If I have to convert this into individual tokens, what I'll do is inside this method I will pass in this object. Now as you see, we had this entire sentence, and since we are considering each word as a particular token, as you see, we have Samay as one token, Raina as one token, is as the next token, the as the next token. Now this is how you are basically able to tokenize your entire sentence into subcomponents. William Smith is saying unable to see. So guys, just give me a confirmation if it's only a problem with William, or others also, if you guys can see my screen or not. If there's any problem, I'll try to adjust the settings over here. Kanishka is asking best programming language used for NLTK or speech recognition. So are you asking which is the best programming language to implement NLP? Then I would say Python because Python has, I mean, not just NLTK, but it also has other libraries such as it has got Spacey, and you can also implement neural networks quite easily with the help of Python. So if you want to implement NLP tasks, I'd recommend you guys to implement it with Python. Abhishek Sharma is asking, is Python prerequisite for AI solutions? So Abhishek, the answer would be AI is a technology, and if you want to implement that technology, you would need some tools. Now, these tools could be either Python, R, or Java, or even Julia. But most widely, the language which is preferred in the industry and by most of the AI engineers is Python, because most of the deep learning frameworks such as TensorFlow, Keras, PyTorch, all of these they were built for Python, and also they're very intuitive. So it's easier to work with Python if you want to implement AI tasks. Nishant is asking, is NLP available with programming language? So NLP again is a concept. It's a domain under AI. Now, if you want to implement NLP, you can either implement it with, you can implement it with Python, you can implement it with R, you can implement it with Julia. So, language is just a tool, Nishant. So, it's just that different languages provide you different libraries. So, as Python provides libraries such as NLTK and Spacey, similarly, R or Julia or maybe even Java, if it has a library, then they would basically provide different libraries to implement all of these. Techno World is asking what is Scapy? So it's basically Spacey, not Scapy. Spacey is another library in Python which is used to implement similar NLP operations. Mohammad Raja is asking which language is best, Python or R. So that would depend on what you're trying to implement. So let's say if you want to, if it's a statistical task, now you would go ahead with R because R is a language which was developed by statisticians for statisticians. So if you want to implement any sort of statistical analysis, then R should be your go-to language. So also when it comes to EDA, so EDA is basically exploratory data analysis. So that comprises of data manipulation and data visualization. So those tasks can be implemented with R as well because R is a very good tool when compared with Python for EDA and statistical analysis. But if you talk about neural networks or when you talk about implementing deep learning tasks, then Python is much more widely preferred than R because most of the deep learning frameworks were built with respect to Python. I mean, even though R has those frameworks, but it's more intuitive to work with Python than in R. And also Python is it helps in variety of applications. It's just not limited to AI and ML tasks. With the help of Python, you can do web development, game development. You can also perform a lot of other different tasks. So I'll take up the rest of the questions later on. You guys can keep posting over here. So we have just had a look at word tokenize. So with the help of word tokenize, you are able to divide the entire sentence into single tokens where each token was basically a word. Now similarly, what we are going to do is we will import the sentence tokenizer. Now let's say if we have a paragraph, then from that paragraph, each individual sentence will be taken as one token. So over here, I have this paragraph over here, and in that paragraph, the first sentence is Samir Raina is the best chess streamer in the world, and Sagar Shah is the best chess coach in the world. And I'm storing this in this object called as chess2. Let me actually import this library first. So now that is done, I'll just go ahead and store this sentence in this object called as chess2. Now after this, if I have to tokenize this, all I have to do is use this method which I have just imported, and inside this method I'll pass in the chess2 object, And as you see, we had this entire paragraph, and that has been divided into two tokens. The first token is the first sentence, and the second token is the second sentence. Now, also the result, if you look at the result of both of these, you see that this is actually a list of values. So the token values would be stored in a list. So this is what is known as tokenization. Now let's say if we want to see how many tokens are present in the, how many tokens are present in that particular sentence or maybe that particular paragraph, we can just use the LEN method, which stands for length. So word tokenized just, so this gave us all of these tokens, and if I want to find out how many tokens are present, I'll just pass this inside the LEN method, and as you guys see over here, we've got 10 tokens. Now, after this is done, we'll understand the concept of bigrams and engrams. So now what happens is, let's say if you when you say something to Siri, such as what is the distance between Earth and the Moon, or will it what is the possibility of rainfall today, or maybe even let's say, Siri, do you love me? So how is Siri able to understand all of these sentences? Or maybe let's say when we talk about WhatsApp, then you have the auto completion, right? So let's say if you're typing hello, how are you? If you just type hello, how, then you automatically get the suggestion of are you over there. So how is this possible? So over here we use these concepts called as bigrams and engrams. Now again, we will just create another paragraph over here, a couple of sentences, and we'll store this in this object called as astronaut. So here we have the sentence, can anybody hear me, or am I talking to myself? My mind is running empty in the search for someone else, and we store this in this object called as astronaut. Now after doing this, we'd have to tokenize this. So we are going to take every single word as a token. So for that purpose, we'll use word tokenize and pass in the astronaut object inside this and store it in a new object called as astronaut token. Now I have something known as bigrams method. So I'll use nltk.bigrams, and inside this I'll pass in all of these tokens and I'll convert them to a list. So what happens is, if it's bigrams, then we are basically feeding two tokens at one time to the machine. So we will feed can anybody. Then we have anybody here. After that we have hear me. Then we have me or. After that we have or am. Now the perfect example of this is auto completion. So there would be millions of people texting every day, and there would be some common words which are generally used. So let's say if you type in good, then mostly what people send us, it'll either be good morning, good evening, or good night. Now what happens is, let's say if we send a bigram over here, then you can either have good morning, good evening, or good night. So this machine or this assistant learns all of these bigrams, and it immediately knows that if the first token over here is good, then there is a very good possibility that the second token is either morning, evening, or night, right? So you've got millions of words which could be possible. Now let's say after good, you don't really say maybe a good eye or good me or maybe even good bottle, right? Because that is the probability of that happening is very less. Now similarly, let's say there's a sentence called as how are you. Every day people send millions of how are yous through text. So let's say if someone sends how, then there is a very good possibility that if the first token is how, the second token is are. Then similarly, let's say if you have how are, then after are there is a very good possibility that it is followed with you. So this is where bigrams come in. Shreyosi is asking, what is a token? Please let me know. So you can just consider a token to be the smallest individual unit in a language. So that is totally dependent on how you want to see it. You can either have a single character as a token, a single word as a token, or maybe even a sentence as a token. LR is saying, please share the notebook. So you will have the link for the notebook and the PPT in the chat, so you can directly get it from there. 3OC, you will get the offline material in the description itself. Amit Kumar is asking, can Python be used in automation? Yes, Python can absolutely be used in automation. Ashutosh is asking how much time is required to learn R. Well, if you let's say if you already know Python, then R is very easy to learn. If you already know Python, then maybe I'd say around 1 week to 10 days at max, because both of the languages are very similar and the syntax is also very similar. So if you already know Python, then I'd say to to have the basic understanding or to have the basic expertise, I'd say it shouldn't take you more than 1 week or 10 days. But let's say if you haven't worked with Python, then maybe add another week on top of that, because I personally find Python and R to be very simple languages. So you can you can go ahead and easily learn R. It will not take a lot of time. Right, so this was bigrams over here. Now we have a similar concept called as trigrams. So in bigrams, we were passing in two words at a single time. What happens in trigrams is we'll be passing three tokens at one single time. So here we've got this method NLTK dot trigrams. Let me click on run over here. And as you see, we are passing in three tokens at a single time. So we have can anybody here. After that, we've got anybody hear me, then we've got hear me or, after that we've got me or am, then we've got or am I. So this is how the sequence progresses. And after trigrams, we have something called as engrams over here. So basically, after you extend three tokens, then it basically becomes engram. So if you have four, so as you see in the method over here, so if you given the value of 4, then you will have 4 tokens being fed at the same time. If you have 5, then you'll have 5 tokens being fed at the same time. Similarly, if you're given 10 over there, then you'll have 10 tokens being fed at the same time. So as you see over here, this has two parameters. First parameter is the list of tokens. Second parameter is the value. And as you see, I want 5 tokens at one single time. So this is a 5 gram concept over here. And I've got 5 tokens. Can anybody hear me or? This is the first token, or basically the first input. Then we've got anybody hear me or am. This is the second input, and this is how it goes on. So this was something about bigrams, trigrams, and engrams. And if you want to know the implementation, then the implementation would mostly be auto completion. Then we have something known as stemming. So stemming is a very simple concept. Now let's say whenever you're speaking, then there would be root words, and these, when you add a suffix or a prefix to these root words, it the meaning, or maybe it sort of becomes a new word. So in NLP, it's very important for the bot to understand what exactly is the root word. So if it knows the root word, then it can actually understand the meaning of it. So here we have this method called as portostemmer. So we'll be importing portostemmer from nltk.stem. Let's go ahead and import this, and then we'll go ahead and create an instance of this. So here I am creating an instance of portostemmer called as mystem, and after that I'll just so let's say if I have any word over here, and if I want to find out the stem or the root of it, I can just pass it inside this method. So this is the instance, and over here I type in mystem.stem, and inside this I pass in this word called as eating. And as you guys see over here, the root or the stem of the word eating is eat. Similarly over here, when I pass in going over here, then this tells me that the root word of going is go. And when I pass in shopping over here, I see that the root word of shopping is shop. So this is also another important feature of NLP. Let me see if there are any more questions over here. LR is asking why we splitting, because it's very important to split the sentence into tokens, and if you don't do that, then the bot will basically not understand what is the individual, what is the smallest unit in it. So you have to clearly specify that this word or this sentence is the smallest unit that I'm going to give you as input. And depending on that, it will understand how to process the input. Sriram is asking, does Great Learning offer all of these for free? So whatever courses you find on Great Learning Academy, rest assured all the courses are free. You don't have to pay a single penny for that. And to get the certificate, you have to we have a certain quizzes, assignments, or projects. So once you complete those, you will get the certificate for that. Silly Points is asking what would be the industry applications of Trigram and Engram, what is preferred more. So I've just given you the industry applications of Trigram and Engram. And if you ask what is preferred more, if you ask if a trigram is preferred more or an engram is preferred more, that is totally dependent on what you're trying to solve. Let's say you would basically, if you're if a machine has to understand something, then it would it would need to know what are its preceding words. If it knows its preceding words, then it will be very easy for it to predict something. So let's say if there's a sentence such as I will be visiting Eiffel Tower in Paris. So now if you let's say if you are knowledgeable enough, then you already know that Eiffel Tower is in Paris. So over here, let's say we will feed all of the information about Paris and all of the information about grammar to this machine. And let's say as a human, we are able to predict this. So let's say if I just give you Eiffel Tower is, or I'm going to visit Eiffel Tower in dash. Now, for us, we can easily say that it's Paris because we do know that Eiffel Tower is in Paris. Now, but and we were able to say this because we were able to look at all of the preceding words, right? I will visit Eiffel Tower in. Now, when I understood all of these words together, that is when I was able to say that the final word would be equivalent to Paris. And this is what is happening in engrams. When we give the preceding words to the machine, it will be able to understand the context of what is the new word or what is actually the sentence about. So I hope this helps you out. So we've got stemming, and after this we have something known as POS tagging. So again, if in fourth or fifth standard, you would have learned something about parts of speech. So parts of speech are basically nouns, pronouns, adverbs, adjectives, and so on. Now, also if a machine or a bot has to understand the basics of, or basically understand what is the sentence about, then it has to know what each token is or what is the part of speech of each token. So that is why we'd have to tag each word with its part of speech. So here again we have this sentence called as Tom Hanks is the best actor in the world, and we have stored this in this new object called as Tom. Now again, as I've told you, it's very important to tokenize each word. So here we have word tokenize, and inside that we pass in this object called as Tom, and we store this in this new object called as Tom token. Now, after we create the set of tokens from this sentence, we can just use the POS tag. So here we are using nltk.pos tag, and inside that we are passing in Tom token, and as you see, this immediately gives us what is the part of speech of each particular token over here. I see Tom. So over here N and P means that it is a proper noun. Tom is a proper noun. Hanks is a proper noun. Is a verb. The is a determiner. Best here is basically it's an adjective. So JJS, it stands for superlative adjective. And then you have actor. This again is NN stands for noun over here again. Then you have N. So over here IN, I'm not really sure. You guys can check it out over here. So all of these abbreviations you can check out. The you can you can just type in let's say uh, what is the abbreviation of all of this for NLTK, and Google will tell you what these basically mean. DT over here, it again means that it's a determiner. World over here again means that it's a noun. So this POS tag method automatically tags each token with a particular part of speech. So let me see if there are any more questions over here. Rajsekhar Reddy is asking, is NLP supervised or unsupervised learning? So I'd say it's a hybrid of both, but it's mostly supervised learning because you would have to give it past data. Now here, past data is basically the preceding data. So it would look at the preceding data and then it will be able to predict what the new word is. Again, you'd have to teach this. So let's say if now when you ask Siri, am I the most handsome person in the world? So here, for it to understand the sentence, it would have to be fed this sentence millions of times, and it has to be trained in such a way that it has to understand what each word means, the syntactical meaning and the semantic meaning of each word over there. Right. So let me just carry on now. So this was POS tagging. After this, we will head on to named entity recognition. So in named entity recognition, now till now, we've so as you saw in POS tagging, we had it tagged all of these as nouns, verbs, or determiners. Now mostly in real world, we'll have a lot of nouns, and again those nouns. So let's say as a kid, you would have played something called as name, place, animal, thing, right? So that is what this named entity recognition method does over here, or this concept does over here. So let's say if you have a person, then it recognizes the person over there. Similarly, let's say if you have something, a place over there, it recognizes the place as a geographical entity. Similarly, if you have maybe an object over there, it recognizes the object as as belonging to some particular domain. So if we have to perform named entity recognition, we have this method called as any underscore chunk. So we'll just import any underscore chunk from NLTK, and then again we'll have a new sentence over here. So I have this sentence which is Barack Obama was the 44th president of America, and I'll store this in this object called as president. Again, our first task would be to convert this or to divide this into individual tokens. So again, I have word tokenize method over here, and I pass in this sentence inside word tokenize, and I store the result in president token. After I have the individual tokens, then I decide to add the parts of speech to each individual token. So I use the method nltk.pos tag, and inside that I pass in president token and I store it inside president underscore pos. And finally I have this method any underscore chunk. So inside any underscore chunk I pass in president pos, and as you see, this method was, it automatically identified that Barack is would actually denote a person. Similarly, Obama would denote a person over here. And when you have America, so as you see America over here, so you have this keyword called as GPE. So GPE stands for geopolitical entity, which basically means that it's a place. So this is what we can do with named entity recognition. So these were some basics of natural language processing. So let me go ahead and look at some more questions. TechnoWorld is saying the link not give any notes for this session. So TechnoWorld, you will have the code file for this session. So you can go ahead and download the code file and implement it yourself. Pankaj is asking where can we learn Python. So We've got a lot of Python courses on Great Learning Academy itself, and once you complete those courses, you will have the course completion certificate. And also, we have Python tutorials in Hindi and English on our channel. You can check out those videos as well. Right, so these were all of the basics of natural language processing. Now, finally, we will come to the main part of today's session, which was converting text to speech. So it's a very simple code over here, and to do this, we would need a library called as GTTS, which basically stands for Google Text to Speech, and we'd have to install this library first if we haven't yet installed this. So to install this, we'll just type in pip install GTTS. So let me just click on run, and let's just wait for this to be executed over here. Silly Points is asking, how will our system know Barack Obama is single person or two-person? Right, so this is a very good question, Silly Points, because the system, you need more processing over here. Only when you process it more, only then it will be able to identify that this is actually the name of a single person, and this is not the name of two individual people. So as you saw in the result, we had person. So you had the tag of person after Barack, and you also had the tag of person after Obama. Right, so this is where you would have to train the model more or the chatbot more to understand that this is the name of a single person. LR is asking why have I changed to Google Collaborate, because I hadn't installed GTTS on Jupyter Notebook, so and it's also easier to install over here, so I have switched to Google Colab. Amikar, you will find the link in the chat itself to download the notebook. Sudhir is asking, does it need internet to process task, whatever is said, or it can work independent? I mean, all of these machine learning models. I mean, let's say if you have a phone, and let's say if you ask something to Siri, you don't need internet connection for Siri to respond, isn't it? It's the same with Google Assistant as well. Even if you don't have internet, Google Assistant is able to reply you. Abhishek Sharma is asking what kind of training model is required for text to speech. So normally we use something known as LSTMs, but here we are, this is a very simple code. So you don't have to implement all of the backend neural networks over here. So that will be very cumbersome. But normally if it's anything related to text to speech or maybe text processing or maybe speech processing, that is normally done by LSTMs, which is a special type of recurrent neural networks. So LSTM basically stands for long short term networks and long short term memory networks. So as the name states, so let's say if you have to convert a huge text into voice, then you would have to know what is happening. You would have to understand the entire sentence. You would have to understand the prefix of the sentence, the suffix of the sentence. So this is where the long short term memory networks come in. Pankaj is asking how much of machine learning is required for NLP. For most of the tasks, if you're working with LSTMs or RNNs, then you would have to know the basics of all of this. Right. So now we'll just come to the main part of today's session, which is let's see how can we convert this. So here, first we'd have to import this method called as GTTS from the same library. So here we are typing in from GTTS import GTTS. Once that is done, we would have to import a method called as audio from ipython.display, and with the help of this we'll just be able to play something. Then this method, it automatically converts the text into a wave file. So WAV file is basically a sound file. So all I'm doing is using this method GTTS, and inside this I will pass in this text, and this basically gives me a text to speech object. So as you see, this text object will be converted into a speech object, and I'm storing that in this object called as TTS, and I'll save this as a wave file, and the name which I'm giving or I'm saving it is 1.wav. And after that I will just store this in a new object called as sound file, and with the help of this audio method which I had just imported, I'll play this. So audio, the first parameter is the sound file which I have created, and I'll just set autoplay is equal to true. Uh, so I guess I hope you guys can hear this. Let me play this again. So as you see, the text which was written over here, it has been played successfully over here. So as simple as that, guys. So we are done with text to speech as well. So let me go ahead and see if there are some more questions, and then we can just wrap up the session. Harish Kumar is asking, can the same be implemented in Raspberry Pi? Yes, the same can be implemented with Raspberry Pi. So Raspberry Pi, it's mostly used for implementing IoT tasks. So yes. Navneet is asking, how can we implement NLP? Please suggest some ideas. So Navneet, we saw some basics of NLP today. So when you combine all of this, that is when you'll be able to perform more such complicated tasks. Mohammad Raja is saying collab is best for everything. That totally comes down to preference. Some people prefer Jupyter Notebook, some people prefer collab. And also, actually, you're partly true because you don't have the hassle of installing new libraries over here. So as you see, this library, when I tried to install it on Jupyter Notebook, there were some issues. But when I tried to install it on Google Colab, I did not find any issues at all. So that is why I ran this command on Google Colab and not on Jupyter Notebook. Ranveer Singh is asking how much time will it be required to learn Python. So it shouldn't take much time. So let's say if you already know some other languages such as C and C++, maybe it should take around 2 or 2.5 weeks to learn Python. But if you're totally new to programming, then maybe give yourself a month's time and learn it comprehensively. Right, guys. So I don't see any more questions, so I guess I can just end today's session. So, guys, thank you very much for attending, and I'd like to tell you about Great Learning Academy again. So, if you want to learn more about NLP, AI, ML, or even stats, digital marketing, or even cloud, you can check out the link for Great Learning Academy over here. So, once you complete these courses, you will also get a course completion certificate, and you can add that onto your resume. And you can also find the link for the app in the description. So let's say if you don't have your laptop with you right now, and also maybe if you prefer learning through a phone, then you can also download the Great Learning app. So guys, thank you very much for attending the session, and I'll be signing off for today. Thank you and stay safe.